All right, we're live. Welcome to the first State of the Community meeting for OpenMined. We've got a couple people here who have been doing some of the recent work on the project, and we're just going to go ahead and use this as a 5 to 15 minute video to talk about progress in the project, as well as places where we can still improve and areas where we actually need help. So this is also a little bit of a call to action as well for anyone looking to get involved in the community and get started on a project, especially get some of the newer individuals to the project up and going. So with that said, Andrew, I think we have a couple announcements on just the heartbeat of the project and metrics and wellness. You want to talk about that real quick?
Yeah.
Oh.
Yeah, definitely. So we've it's still been a pretty awesome last couple weeks. So we've had around 150 new people join our Slack community, which has been fantastic. So we're now up to about 430 people hanging out in Slack. And actually, if you on the analytics page, you can see that that's also a reflective of active development. So we continue to make new highs on the number of people who are actively talking and engaging within the Slack community day to day. So I think while it's cool to see like the general membership go up, it's even cooler to see that in private channels and in public channels we're continuing to make new records for the number of people that are actively engaging in the community, which is really great. We were also featured in another YouTube video that's gotten, I think, around 17,000 views over the last 2 weeks. In addition to the ones we were already in, climbing still very significantly. And I think that's really part of what's been driving new users coming to the Slack community. And then, of course, if you look in the announcements, we've had around a dozen folks become new contributors, and our contributor score is now up to 37 people who have pushed code at one time or another. So thank you very much to everyone who's been learning about the platform and crossing that threshold into doing your first pull request. It's very exciting to see how fast code is coming in. I know particularly in the PySift project, there's just been a lot of new folks contributing their very first pull request. And we've closed like, I think we're up to 55 issues that we've actually closed in the PySift project, which is really quite incredible. So code is coming in, people are active in the community, and outreach is also going quite well. And then there's also a research paper that's coming out of the philosophy department at Oxford that will be featuring us as one of the kind of main platforms looking to build AI safety in the real world, which is pretty cool. So look for that coming out soon. Yeah, so those are kind of the main statistics. Back to you, Patrick.
Yeah, so as mentioned, we're going to try and just briefly go through a couple of the demos that we've got working. Actually, Andreas, I believe you're up first for first milestone hydrogen.
Okay. You unmuted me.
Yes.
Okay, so let's get screen sharing going. So the scope of the first milestone we did was to get the whole system Dockerized. And we finally managed to do that. So it wasn't just me, it was a lot of people, especially Alex Johnson, that put a lot of Docker knowledge into it and helped me a lot. And all the people that accepted my pull requests to get stuff aligned. So what you can do now is basically run this one command, and if you have everything preloaded as I do, you have it pre-cooked always, you should get the whole OpenMined platform running in a matter of seconds. And you can see here it's Docker Compose for those of you that are not familiar with it. It's a framework that allows you to orchestrate multiple Docker containers in one environment. So what you see here is the name of individual containers. So we have IPFS, which is our file hosting. We have test RPC, which is a local mock for the blockchain. We have the notebook, which is the data scientist's interface to publish new models he wants to train to the network. And then we have the mine, which is the individual person with his data, trying to make money out of the data by training models for data scientists. You can already see that the mine currently doesn't have anything to do. And the notebook server also started up. So what you want to do after starting this command is you head over to your browser, open localhost on port 8888. Open the notebook that's there. If you're unfamiliar with the setup, it's Jupyter Notebook, so go and look that up, how they work. Basically, it's wrapping Python code. And then all you got to do is go through this quick tutorial of how can I be a data scientist in the OpenMined platform. You set up your experiment, you interact with the blockchain, and at some point, you submit basically a mock model at this point that is trying to learn how to predict diabetes in patients. So the mine that's used here already has sample data, and the data scientist knows what this data is looking like. So as soon as you submit this model, you will see that, whoopsie, I don't know, I can't zoom. First, you see that the blockchain starts doing stuff. So it's getting a transaction, which is this model coming in. And then at the next time the mine is looking for something to drain, it actually finds this model with no trained gradients at this point at a specific IPFS address. It's downloading the model, it's training the model, it's uploading the new gradients to IPFS. And after it uploaded the gradients, the next step the mine is doing, it's propagating that I just trained this model to the Sonar smart contract. So that's what you can see in between here. Test RPC is the smart contract. So you can see this is receiving a transaction. And then it's done. After that, it just goes back to looping on training. So that is the whole system we have set up, Dockerized. If you want to test it, we will figure out a way to promote this one-liner. All you need is to have Docker Compose installed on your local environment. So that's available for Mac, Windows, Linux, and probably every other system you might have. If you want to help out, what we really need to push forward is get all the individual components that we have, like the PySift library, the PySonar library, the Sonar smart contract, the mine, all those components. We need to figure out a way to really embed and embrace integration testing into the development workflow, because it was, basically it took me the last 2 weeks to get the whole system aligned on the interfaces it has so that everything works properly. So that is one thing. If you are working on a component, please try to think about how can I embed this Docker workflow or Docker testing into my component. You can also contact me, Einolf, on Slack, or A. Johnson, I hope it's okay for him, who can tell, and we can discuss how that might work for you. Another thing that's would be really cool to solve is we need to reduce the build times for those Docker images. So if we look at the Docker Hub OpenMined repository that has all the images we're running, you can see, for example, that I think this one takes particularly long. I should have prepared that. Okay, it doesn't show build times. Anyway, it takes about 40 minutes. So especially all the Python stuff, we need to figure out how to speed up the build times, because waiting 40 minutes for a Docker image is no fun. Yeah, that's it from the demo. If it's not working for you, please message me.
This is awesome. Yeah. Do you have any particular calls to action of, other than increasing build time in Docker, do you have anything else in particular or any special skill sets that you would need to help with development?
Yep. I think we need to figure out a way to make sure that the next time we integrate the stuff, it's not like a big bang as it was now, so that we can have a continuous integration kind of going on during the development and not just for every milestone. So, but I don't have a solution for that. We just have to think about it and discuss it.
Great. Okay, cool. Thanks, Andreas. Next up, I think, is Andrew. You've got a Pallier Tensor notebook that you want to show off.
Yeah, definitely. Great job, Andreas. That was awesome. What a huge step. And I know that I'll try to do my part to make PySift conform to kind of the Dockerized workflow. So yeah, on PySift, for the last 2 weeks, we've kind of built out our first encrypted tensor library. So what I wanted to demo for you today is just sort of a quick demo of what. Can you see my screen? Can you see my screen share?
Yeah, you're good.
Awesome. Yeah, so what I just wanted to walk through today, so this is actually a notebook that you can download from the PySift /notebooks directory, and you can run it yourself. It should run just fine. But what I wanted to lay out is basically, whereas before we had encrypted floats, right? So each individual number had its own object that was encrypted, and then we wrapped it all in NumPy. So interacting with. Whereas that old way of doing things was fine for the first prototype, for all the different features that we want in the future, it's not sufficient. So in this case, what we're doing instead is we're actually going to create these tensor objects that are specific to the type of encryption that you're using. So this is what the one for Pallier looks like. And in the near future, we'll want to do the same thing for BV, for Yashi, and for Aono. Which are the other 3 homomorphic encryption libraries that you've hopefully seen pop up in our repositories. So, of course, you do the imports first, and we generate your public key and private key just like before. However, in this case, whereas before you would actually use your public key to create an encrypted library, and several people who still have the old demo around have logged into the beginner chat or something like that and been like, "Hey, why isn't this working?" And the reason is just we were changing the interface. So this is a breaking change, and it's one I want to make sure you know about. So if you look at X now, this part looks the same. So internally to Pallier Tensor, there's still a NumPy object that has encrypted values, but now we have this wrapper that has various pieces of functionality that you can call on it that knows whether or not you're allowed to do that on encrypted data with this specific type of encryption, because different encryption techniques have different constraints on the types of mathematical operations that you can do. And so the whole point of having these Pallier tensors is so that it can tell you when something goes wrong. So like, for example, we can't do multiplication by another encrypted tensor with Pallier because that's a constraint in this one. And now we get an error where it says unsupported operation type for multiplication between 2 Pallier tensors. Whereas before, it would give you this big, hairy, complicated error, and it might be kind of hard for you to find and figure out what the real issue is. But if we do, generates another Pallier, right? So that's kind of the idea behind building these tensor type objects. And so we can take the tensor, we can call decrypt on it, and that will give us back the original one. And then, of course, the same operations that were in the old demo still exist now. So something that's interesting with Pallier is you can do addition and division by a decrypted scalar, right, divided by 5, but I can't go divided by x, right, because x is still encrypted. So yeah, and then this is left over from the previous demo. That just it's still very, very similar. But yeah, so I just wanted to do a quick walkthrough so that people were generally familiar with this new style of interface. As far as things that we want to build next, so we've got 3 brand new, awesome homomorphic encryption implementations in 3 different repositories inside of OpenMined. One of which I believe Mayank is about to show you. What we would really like to see is sort of a tensor object like this for the other homomorphic encryption types as well. And I believe each of those 3 libraries has already been wrapped in Python at kind of the low level, right? So it's really just about writing more Python kind of middleware to take the basic operations that are over those encrypted in the homomorphic encryption libraries like PyYashi and PyBV and PyAono, and wrapping them in a tensor-like object like this. So yeah, that's the demo. And now back to you, Patrick.
Sweet. One question I actually had, Andrew, if you wouldn't mind answering, is just to ask the question: what's the logic between having multiple different homomorphic encryption methods versus just picking one in particular?
Oh yeah, definitely. So if you saw this one right here, remember how this one? I assume you can still see my screen. Like I can't do X times X. There are different encryption techniques that do let you do this, right? But it comes with a trade-off, right? They might be slower for one. They're you have to do or whatever. So basically, different homomorphic encryption techniques have different trade-offs that are advantageous or disadvantageous for one reason or another. And so by supporting multiple, not only can we evaluate which one is actually best for a specific purpose, but we also have it available for kind of easy packaging when we actually want to allow people to just do encrypted machine learning and not have to worry about the homomorphic encryption under the hood. So yeah, basically, not all encryption schemes are the same, and there's a different time that's most appropriate to use one versus another.
Awesome. Well, cool. I actually think that leads right into Miyank, who's got some more news on his demo.
Yeah. Can you guys hear me?
Yeah, you're good.
Okay. Yeah. So I'll begin with a demo of PyAono, which has already been live on our GitHub. As you can see, in this Python file, you can see that I've generated 3 ciphertexts: CT1, CT2, and CT3. What I'll do is that I'll show you that and multiplication along with subtraction with our
I think we're actually having a little bit of trouble with Miyank. I think his connection's a little bad. If he's able to join back in a second, that'd be great, and we'll try it again then. Amber, you actually have an update on the map. We created a contributor map.
Yeah, so I'm going to share.
And I guess you'll be talking through Andrew's profile.
Sure, let's see.
Oh, great.
Awesome. Is it sharing? Oh yeah, it's sharing. Cool.
Is it? Okay, awesome. Yep. Okay, cool. So this is the team map. It is just a way to visualize where all of our members are in the world. So by clicking on any specific person's marker, you can see things like their local time, their languages and frameworks that they're familiar with, their OpenMined GitHub repo contributions, and things like that. There's also a feature to filter the map by OpenMined repo to see who's working on what. So by default, it shows everybody. But if you click View None, then you can turn on any repo to filter in the markers on the map for people who have contributed to that repo specifically. So like, here's everybody that's contributed to PySift. Turn that off and say Mind.js. That's all of those people, etc. So the people who are included on the map are those who have filled out the new contributors survey, which is here. There's also a link to it in the team map GitHub repo here. So if you'd like to be added, just go fill out the survey and we'll have you added within like 24 hours or so. And then if you're already on the map and there's anything you would like to have changed in your info window, then just let me know via direct message on Slack at 4MBER. There's also a number of ways ways that, and we don't have to go into all of those right now because they are listed in the issues for the team map repo. So that's where you can go to look for different ways to help us improve. And back to you, Patrick.
Awesome, awesome. Sweet. Cool. Oh, wow. There we go. Awesome. Lots of recursion. Yeah, great. So I think that's it. I don't believe Mayank is going to be able to join. If anyone would be curious about what he's doing, of course, message him in the Slack channel. I'm sure he'll be more than happy to present it to you. And hopefully we'll have a better connection in 2 weeks again when we do this to be able to show that off. It's pretty cool stuff. But unless anyone else has anything remaining, I think we're all good.
Awesome. I think that's great.
Sweet. All right. Thanks, guys. Appreciate your time. If anyone, if you guys are interested in contributing to the OpenMined project, of course, just go to our website. You can find us on the Slack channel and so on and so forth. Hope to see you there.